The first bug to fix is issues with hanging. If I try to hang right at the corner of the ledge, it still hangs, but there is not enough space to actually hold on there, so the IK messes up and it looks odd. This also happens when you try to jump into a ledge at a sharp angle. To fix this, first go to the player blueprint. Move the ledge input code and make some space. Disconnect the trace ledge function and the hang event, then connect it separately. Then open the trace ledge function. Add the hit actor of this break hit result as an output. Then get the normal of this other hit result. Make rot from X of it. Split the pin and make yaw an output called normal angle. This will help us determine the angle we jump into the wall at. Go back to the event graph and make more space. Add the trace ledge function and connect it to false of this branch. Now get the actor location and add vector. Add another one too. Then get the actor right vector and multiply it. Duplicate it. Connect each multiply to the add node. Convert the values to multiply to a float. Set them to -30 and 30. Connect the first one to initial location. Duplicate the trace ledge and connect the second vector. The direction for both will be actor forward vector. Next, get a branch. Drag out of ledge detected and add in an operator. The second condition is the other traces ledge detected. Add a pin. The third condition will be if both hit actor outputs are equal to each other. This is so that checking the angle is not disrupted by different ledges. If false, then add a jump node. If true, then copy the trace ledge from the hang event. Next, add another branch node. The condition will be an operator, with first condition being ledge detected. Then get nearly equal from normal angle and connect it to a new operator. The second condition will be another nearly equal. The error tolerance will be 4, meaning it will return true if the values are at a difference of ±4, but you can change this if it doesn't work that accurately for you. Connect each B value to the normal angle output of the previous two trace ledges. If the branch is true, then add the hang on ledge macro and connect the inputs. If false, then jump. I will now test it. It works regularly, but the in-air trace needs to be updated to compensate for this change as well. Copy these trace ledge nodes and inputs. Find the falling trace code and make some space in it. Paste it after the branch node. Change the inputs to -100, 100, and 50 and 25 respectively. Then add a branch node. Check if both ledge detected outputs are true. Also check if both normal angle is nearly equal with a tolerance of 4. I will change the error tolerance to adjust the accuracy so you can climb on more curved ledges too. Here is the updated hanging system. The player will not hang now if they are at the corner of a ledge. The next change is to fix the free hanging position. When braced hanging it looks alright. However, when we transition to free hanging, since we are using layering to simulate free hanging, the upper body position remains the same and it looks really unnatural as the player should be slouched down more. We will be working in the animation blueprint for this fix. First, make a new float variable called pelvis correction. Add it in the event graph after the previous ledge climbing variables. Copy and paste this f-interp to node. Connect it to pelvis correction. For target, first get both ledge as surface variables and the not operator of it. This is since we only want to hang down if both feet are hanging down. Then add an or operator. Connect this to an operator. Add is on ledge to the end. Add a pin to the end for a third condition. Get the character ref and get moving on ledge, get not of this and connect to end. This is since when we are moving on ledge, even if free hanging, we don't want to hang down as the player should be pulling themselves up to support the strength needed to move on a ledge while hanging. Convert this an operator to a float and connect to target. False means a value of 0 and true will mean 1. Then go to the anim graph. Before the 2 bone IK add another transform bone node. We are adding it here since we still need hand IK to work, so hand IK should be done after transforming the bones. Remove the rotation and scale as pins. Set the bone to modify as pelvis. Set the translation to 10 in Y and -20 in Z. You can of course change these values to your liking. The alpha will be pelvis correction. I will rename the variable to pelvis correction alpha. Make sure you set translation mode to add to existing. When alpha is 0 it is normal. When alpha is 1 the player is moved down and forward a bit. Hanging down is working fine now and it stops hanging down when moving. However, there is now an error with hopping. To fix this, go back to the event graph. Add another condition in the end. Get the anim instance of the mesh and is any montage playing. Get out of it and connect to the fourth condition. Now hopping should work fine. Here is the updated system to make the player hang down when free hanging. The next bug is turning at corners. This system is really buggy because of the lack of a proper animation, so I will try to fix it as best I can with this placeholder one, but it is highly recommended you replace with a better one if you have. When trying to turn corners while free hanging, the system doesn't even work at all. Go to the player blueprint and go to the turn on ledge function. Then go to the ledge turn animations. Open the turn right montage. Set the blend out time to 0.7. Set the notifies endpoint to 1 second. For turn left, set blend out time to 0.5 and the montage notify endpoint to 1. In the turn function, first go to this part. Add a pin to the add vector and set Z to 50. Set the Z value to subtract by from 50 to 120. This partially fixed the issue with freehang turning. We changed those values as before the trace was too short to detect ledges that were for free hanging as they are not extruded downwards fully. Then go here and remove the divide code, connect impact point to both add vectors. Then go to move on ledge function where turn on ledge is called and make some space. Due to the animations being different, I need to add a select condition here, so you only need to do this part if you are using the same animations. Add a select float for move to offset and the condition will be move amount greater than 0. This essentially is so we can find if player is trying to turn left or right. Values of 40 and 70 for A and B worked best for me. These are values I found by trial and error which worked best for the system and animations used. The system is a bit less buggy now and turning better. Add a pin here for this add vector. Now open both montages and uncheck ignore Z-axis in the motion warp notify. Set the Z value to -160. It is better now. Go to the animation blueprint and change the interp speed for pelvis correction. You can change it to make it slower or faster if you want. A higher interp speed means it will be faster to interpolate. Here is the updated turning at corners system. The next bug is to do with hopping between ledges. Firstly, you can see that the IK and hand placement is really wonky when hopping. The system also does not work properly between freehang ledges and will try to hop even if the gap is too large. There is also no change of animation if there is no ledge for bracing onto after hopping. First we will update animations. Open the braced hang hop left animation. Modify the pelvis location in the Z-axis, moving it down slightly. Then press Add key on the top. This has made it a bit more accurate in height. You can adjust the animation to your liking. Now make a new folder for freehanging variants. We aren't using the Mixamo freehang ones because of the difference in height. Copy the braced hang hop left and right animations to new folder. Rename them. We will modify these animations using curves. Again, you should use your own animations if you have an animation set or made your own, as this is more placeholder. Rotate the thigh and calf bones and add keys along the animation to make it free hanging as best you can. I will finish them off camera. Here are the two modified animations. Now create montages of the animations. Open the braced hang hop right montage and change the end time to 1.25. Then copy the motion warp notify. Paste it into the two freehang montages, making it the whole duration. Make sure to change the end time of freehang hop right to 1.25 as well. Now go to the player blueprint. Go to the hop to ledge function and to this part. Add a pin in the add vector and set Z to 50 so it will be enough for freehang detection too. Rearrange the nodes here like this. Set has gap to false if the branch is true. Next, in the false path of this branch, add the return node with can hang as false. Now go to this add vector and add a new pin, setting Z to -50 to compensate for the extra 50 we added in the initial line trace. Now make some space. Delete the code after the branch node. Add a sphere trace by channel. The start will be get actor location. Then break the capsule traces hit result. Add a vector to the location and set Z to 25. This will be the end. Set the radius to 20. This sphere trace is used to find a more precise location to calculate the move to value from. Add a branch from return value and if false add the return node. If true then add a capsule trace by channel. Add a vector to this previous add vector. Z will be 50. Set this as the start and end of the capsule trace. The radius will be the capsule's radius. Set the half height to 20. Now add another branch from return value and return node if false. This capsule trace is to prevent hopping if there is an obstacle in the way. Now add a final sphere trace. The start and end will be the trace start of the first capsule trace. Set the radius to 20. Next, add a return node. We don't need to branch out of return value as this trace is just for checking if there is a surface or not. Instead, connect the return value as an output called hasSurface. Set canHop to true. For the location, make a vector. Subtract a vector from this hit results location. Set Z to 80 and split the struct pin. Connect Z to the make vectors Z. Then break the hit result of the sphere trace. Add a vector to the impact point. Add a multiply node for the vector to add. The first value is get actor right vector. Then get a select float and connect it to the multiply. Get the direction input and greater than for the select condition. A will be 65 and B will be 35. Add a pin and connect direction to it. Add a pin to the add vector. Get actor forward vector and multiply it by -45, then connect it. Split the add vectors pin and connect X and Y to the make vector. Change this value to add by to 90. Before the final sphere trace, set hand IK target alpha to 0 as well, since we should not use IK while hopping. It is working, but still some hand position issues. Open the ledge hop component macro. Subtract 15 in Z from the location before connecting to make motion warping target. This fixes the issue. You can change the value to subtract as well as readjust the curves in the animation until it looks right. Now we will add the free-hanging animations. Go to the event graph and make space in the A and D key inputs. Add a select node for the montage to play, and the index will be the hasSurface output of hop to ledge. If true, then it will be braced; if false, then free hang. Connect the corresponding animations for each direction. It is working now and is a lot more accurate. There is one final issue to fix, which is when gaps are too large it hops to the previously hopped location. Go to the hop to ledge function and make sure in all these branch conditions after the traces, if false, then it has a return node with canHop as false. Here is the final updated hopping mechanic. As you can see, if I hop to a location where there is no surface, the freehang one plays. But if you hop to a location where this is surface, the braced one will play even if there is not a surface at the current location. If the gap is too large between ledges, then the player will not hop. The final bug to fix is that we need to make sure you can't turn back and jump if the player is free hanging, since realistically to turn back and jump while hanging you need to have a surface to plant your feet on to build up the momentum to actually jump. If free hanging, this would be extremely difficult or not even possible at all. This is a really simple fix. Go to the event graph and find the left control input code. Make some space after the branch on pressed. Add a branch node. Get both ledge has surface variables and get an operator. If true, then connect it to looking back. This is all we need to add to fix this. Now the player can turn back if both feet are braced. But if free hanging, then cannot turn back and jump. For the first optional addition, I will be replacing the foot placement system to be single rather than each leg hanging down individually based on if there is a surface. Go to the animation blueprint first. Go to the foot alpha code and disconnect the knot. Add a select node instead and the index will be a boolean. Promote it to a variable called use separate feet placement. If you want individual feet placement, then you can tick this variable, otherwise leave it false. Copy these nodes for false and true path. Copy and paste it for the right foot alpha too, but swap the ledge has surface variables. Now go to the player blueprint. Go to the tracing for surface code. In the multiply vectors, add a new pin. Add a select float and connect it as the new value to multiply for both. The condition will be moving on ledge. A will be 3 and B will be 1. This is so that when the player is moving on the ledge, it will anticipate in advance whether the should be braced or free hang. Now the player will free hang or brace based on if there is a surface to place feet on, but it will not do each leg separately and looks a bit more realistic this way. It also anticipates in advance before you actually move to the location if you should free hang or brace. The second feature will be modifying exiting the ledge to include animations. First go to Mixamo for the animations. Download braced hang drop and free hang drop. Make sure to download them without skin as we don't need the rig. Then use the Mixamo converter to convert to Unreal Skeleton. Make sure to set frame, height, and rotation to 0. This is since we need the root bone to move in Z-axis as explained in the software. If you do this and the animation in engine has not got Z movement for the root bone, then delete the output, set the values again and convert, then go in engine and press reimport animation. Make a new folder for the drop animations and import them. Bulk edit both of the animations and enable root motion. Then create a montage of the braced drop. Find the point in the animation where the let go of ledge part ends and set it as the end time. Add 0.25 to it to compensate for the blend out time. Now make another montage of it for braced hang landing. Set the start time to when the landing part plays. Do the same for the freehang animation too. Now go to the player blueprint and make some space in the exiting ledge part. If this branch is false, add a play montage for the mesh. Get the set hand IK target alpha to 0 and plug it into the play montage. Connect the rest as well. For the montage, add a select node. The condition will be both ledge has surface variables within an operator. If true, then play the braced hang drop, if false then it will be free hang drop. Make sure you connect the rest of these nodes to on blend out and not on completed. Make sure you add 0.25 to the end time of free hang drop too. The dropping part now works, but it looks too slow. Increase the speed of it by increasing the play rate in play montage. Make a new Boolean variable called drop from ledge. Set it to true after setting the hand IK target alpha. Finally go to event on landed. Add a reroute node from the sequence. Add a branch that checks if drop from ledge. If true then play montage. We will choose the animation based on if it is a hard or soft landing. Add a select node for the montage. Get the last update velocity of the character movement. Split the pin and get the absolute value of z, meaning the positive value. Check if this is greater than 400 for the index. You can adjust this value if you want. If true then set it to the braced landing, if false then the free hang landing. Then set drop from ledge to false. Here is the new exiting ledge system with animations. You may need to add some extra Boolean checks to movement input to prevent input spamming. Different animations play based on the velocity at which the player hit the ground. The final addition will be making only certain objects climbable. This will be useful to regulate what objects in the game the player can climb on, as you may not want them to climb on all. First go to project settings. Make a new trace channel with default response as ignore. Name it ledge. Make sure you create a new trace channel and not object channel. Then go to the player blueprint. Make a new Boolean variable called use only climbable ledges. If you want to climb on any objects, leave this variable unchecked, but if you want to only climb on certain objects it should be true. Then search for trace by channel in the find results. If you don't have this, press the find button at the top. The first two line traces are for checking if ledge has surface, which does not need to be updated for this, as even if we are climbing on certain ledges, other obstacles should determine if we are braced or free hanging. The next two are for climbing up. This also does not need changes as we should be able to climb up to any surface, not just certain ledge objects. Next is this line trace for falling air trace. This also needs no changes as it is checking the distance between the player and the floor, which is generic. Next is sphere trace in the trace ledge function, and it does need to be changed. Add a select node for the trace channel with the condition being the Boolean variable we created. If true, then the channel will be ledge object, otherwise visibility. Convert this into a function called select ledge trace channel. Set it to a pure function. Add it to the second sphere trace in the function. Next is the traces in the hand IK function, which we will not change as the ledge may have some other objects that affects hand placement, but it is not a ledge or wall to climb onto. Next is line trace in move to ledge. Add the select trace channel function here. Next is line trace in turn on ledge. Add the function here as well. We don't need to add it to the other two traces here since they are checking for obstacles. Next is the traces in hop to ledge. Add it to all the traces in hop to ledge except the final sphere trace, as that trace is checking for surfaces. Set the variable to true by default. Now the player can't hang on any objects. Go to collision in project settings. Make a new preset. Call it ledge object. Set collision to collision enabled query and physics. You can add any description you want. Now set the response of ledge to block. Then select objects you want to be climbable. Search for collision and set the collision presets of it to ledge object. Here is the system in game. As you can see, objects with object type default will not allow the player to hang onto them. However, objects of type ledge object will. That is it for this video. Here are a list of all the features in the ledge climbing system. I have also included some suggestions you can make. Some of these were omitted from the series due to a lack of animation, and the last two was omitted since it is just adding bug prevention using branches, which is pretty self-explanatory. You can purchase this project using the link in the description if you want. If you enjoyed, like and subscribe for more content. Thanks for watching.